Well, good evening, everyone. Welcome to our this evening's 7 for 7 YouTube live event. I'm Kevin Spry. I manage the TQ Professional Development Group at Texas Instruments in their ed tech group. The 7 for 7 sessions, they're something that we host at our annual T³ International Conference each year. And we select 7 educators to talk about something that they're very passionate about in education, and they each have 7 minutes each, hence the idea of 7 for 7. And I'd like you to introduce you tonight to one of our 7 for 7 speakers that we've had. It's Linda Antinone. Hi, Linda. Good to see you this evening. Linda's been a T³ national instructor since the 1990s. Her most recent teaching position was as the math department chair and physics teacher at Pascal High School in Fort Worth, Texas. And now she spent the last year as an Albert Einstein Distinguished Educator Fellow in residence in Washington, D.C., focused on STEM education. And she's been working in the U.S. House of Representatives. She's continuing her work on equity issues for girls and underrepresented groups in STEM. So we're really excited to have her here with us this evening, and an opportunity to watch her presentation as part of the 7 for 7. And then we're going to open it up during the presentation and afterwards for questions for Linda, and we'll be able to discuss with her a bit more about what she's presenting. So Linda, which is your presentation title for tonight?
Hi everybody, my presentation is our role in leveling the field in STEM. And this has been one of my passions to help every student to be successful in STEM and to encourage more students to do that. So here it is.
Okay. All right.
So we hear a lot about we need to get more students interested in STEM. But I'm here to talk about what do we do as teachers in our high school classroom to promote equity and increase the numbers of underrepresented groups in STEM. So if you're thinking, why do we need to do this? Well, only 13% of engineers are female. Now, back when I was in college, and there were very few females, I thought that by now it'd be a lot better. If you look at Hispanics, that's 11%, African Americans 9%. So that means combined African Americans and Hispanics only make up 20% of engineers right now. So I think, why is this? So what I want you to do is close your eyes, think, what do you see when you think of an engineer, a physicist, a scientist? Then look up here. Lots of our students see images like these. Well, quite frankly, I don't see myself up there or anybody that looks like me. And so why would I go into one of these fields? When I took my kids to see Cars, and my daughter was 4, she looked over at me during the movie and she said, "Mommy, where are all the girl cars?" And I thought, whoa. She's making decisions at 4 years old based on the things that she's seeing about what she can do in her life. And that's true for a lot of kids, but I didn't realize it in the same way until my own daughter said it. So I want to know, what can we do to change the images that we have to be more like these people? These are all some of my former students who are engineers and scientists. So I asked them, hey, what can we do? What advice can I offer to you? And they said, these are the things that we can do. 1, we need to recruit students and support them. Number 2, people can be diverse. They can be dancers, cheerleaders, musicians, football players, as we saw today, and still be good in math and science. We need to provide challenges, but at the same time, we need to support our students. We need to encourage that growth mindset that we're hearing a lot about. And we need to design our courses to provide an environment that promotes success for all and not just for some students. Trevon, he said, "Don't forget to tell them how you found me in the hallway after class has already started, dragged me in and made me take your class." And then he got a 5 on the AP Physics exam. Wouldn't have done that had he not been in there. We look for kids in our building. We work as a team. We use AP Potential, but we also talk to each other to find people and encourage them to take the highest level classes that they can, and then support them to help them be more successful. Sarah said I helped her realize, she's a PhD in physics working at the National Lab in Los Alamos. She said I helped her realize that she could be girly and still be in physics. So I told her some stories about my experiences, especially in physics, more so in math. And here's a couple of those stories. One of them, I was at the American Association of Physics Teachers making a presentation about 20 years ago. And I went in the restroom, and a woman came up to me and she said, "You're wearing nail polish." And I said, "Yeah." And she said, "Women don't wear nail polish at the AAPT meetings if they want to be taken seriously." And I looked at her and I said, "You're wearing nail polish?" And she said, "I know, I'm so excited to meet you." And we've been friends for 20 years. At one of the other meetings for AAPT, I was sitting in the audience and it was a sharing session, and a male teacher got up and he said, "This is a demo I do with my conceptual physics class. You know, the one with all the football players and cheerleaders in it?" Well, as a former cheerleader, I was not happy. So I chased him down after the session. I'm sure I was not as intimidating as John Urschel, but I said, "Hey, I was a cheerleader, and I don't know what you're saying, but this is offensive, and I have AP students who are cheerleaders and football players in AP physics, and I want to know why you don't." I chased him down the hall. He finally escaped to the men's room. But these expectations, we know, impact our students. And so when we have those expectations, a lot of times they see those. Sarah was in an on-level geometry class until her teacher encouraged her to come in. Daniel says we need to care about our kids and help them. That as an immigrant, a lot of his parents didn't know how to help him, but his teachers helped him and encouraged him. Emily said, "It's really more fun and exciting when we work on something that's difficult and succeed in that than when we succeed in something that we know everybody can do." So I encourage students to do that. Whew, okay. We need to expose students to real-world data, collect data with them, show them real-world problems, because as Gustavo says, the real world is all we have, and there's no solution manual out there. Amrita said we need to support our students and allow them to make mistakes, which is what we keep hearing. But if that's what we believe, then we need to create a classroom that does that. So we allow test corrections no matter what. If a student makes a 95, they can still get extra credit and come in and learn the things that they didn't learn, okay? They don't have to know it all the first time, and we encourage that all the time. Sophia says we need to encourage a growth mindset, that a lot of students think some people get it, and they have it. They don't realize all the hard work that goes in to those students being able to really understand it and how much thinking and all that stuff that they do. And so as we keep hearing, we need to encourage that growth mindset. We did design our courses for success. Now, this is on my board in my classroom all year long for AP Physics. You only need to get about 60% right to get a 5 on the AP Physics exam, and about 50% right to get a 4. So why should I create my tests where students have to get 90 or 80% right? Okay, I make my tests out of 120, sometimes 140 points to allow them to make mistakes. Then they come in and correct and learn how to do the things that they didn't know how to do before. It encourages them that it's okay that they don't know everything, that they come back and learn it, and I give them incentives to come back and do that. Finally, we need to encourage students to work together. Our leadership team at our school talked to our faculty and said, create a seating chart like Ms. Antinone does. Put students in groups together. Don't let them choose their own seats, because we know that they're going to segregate by race, by socioeconomic level, and by the people that they know. We have a moral obligation to move kids around and help them get to know each other. And when they do, they said, we didn't want to change groups at the end. We made new friends. By the end of the year, we felt like it was a family. These are the choices that we make in our classrooms that can impact a lot of these students. Some of them have come back and said, I'm not feeling this in other classrooms, so this is what we need to do. We can't control everything, but we as classroom teachers can design our classes and use our influence to help level the field in STEM. So let's go out, change the world, bring more kids in. Thank you.
Wow. Excellent. Wow, boy, 7 minutes goes quickly, doesn't it? I'm sure when you try it through. But what I'm really excited about is that we have Linda here tonight, because one of the challenges of the 7 for 7, you have 7 people going through and it's boom, it's gone. There's the hour. we have an opportunity to be able to talk a bit more with Linda about her presentation, and an opportunity for you, if you wish, to be able to ask questions here on YouTube Live, and we can get started. So Linda, are you ready? We'll give you, we got more than 7 minutes now. So.
Yeah, and how do they send in their questions, Kevin, just in case anybody wants to ask a question?
I believe it's through on the YouTube part. They can enter it in on the chat window. I think there's a way. Yeah, it's on the chat. Great, thank you.
This is our
All
first
right.
one, so
Yeah,
we're just, you know.
We're just having fun. Okay, so well, one of the things though I want to jump into, I don't wear nail polish, but anyways, I love that. Yeah, and I'm not an engineer. So in terms of, I love that comment, that idea that women don't wear nail polish. It's sort of this national physics teacher meeting. That comment in regard to the whole idea of stereotyping. What would you advise teachers to tell their students when it comes to the idea? Because I've heard when I was teaching, students would repeat often the stereotypes. How as a teacher do we need to address those?
Well, I think one of the things we want to do is make sure that we are expecting the same things of all of our students. That when we look at students and we see differences in all kinds of ways and lifestyles, that we're not making judgments about them based on that and thinking, oh, this kid probably isn't going to be very good in my class. Because that's when we like pigeonhole kids in, and they recognize that. And some of these kids, I've felt lots of times and some of it might be just my own insecurity, especially back when I was younger, thinking, my friend who talked to me in the restroom about the nail polish, after she said that, she said, and you know what you're talking about. And I was like, well, that's good too. I know what I'm talking about, and I wear nail polish. But I think we need to have those expectations, and we need to be able to expect the same things from everybody, and not make those judgments. And then they see that. And when, some girls, like even when I talked with Sarah, and even talked to her as she was going along in her degrees, through her graduate degrees. And she would say, oh my gosh, some people might not think I'm as smart as I am. And I said, you just keep changing their minds. You just keep showing them what you can do. I know you can do it. And I think that's another thing, is sometimes when we say, I know you can do this, that makes an impact on students, versus when we say, oh, well, maybe you're not that good at, okay, it's okay if you don't do well. I say, come on, you can do this. I'm going to help you.
Wow, that's wonderful lead in actually to our first question that's come through on the chat for this evening. And I'll just read it for everyone. It says, how do we create systemic changes in STEM education that foster risk taking and allow students to make mistakes and learn from it? I know you touched on it a little bit in the talk, but do you have some more thoughts on that?
Well, I think that is really part of what we need to do in our classrooms. A lot of times we expect students to be, okay, you've got to get 90% right, and then you're going to get an A. And we look at those kids and we say, you people are going to be the scientists and engineers. And I've had kids, I remember when I was younger in my career, and I'd have these kids who were making C's, and then they'd say, I'm going to be an engineer. And I'm thinking, you're making a C in here. And then they'd come back a few years later and they were engineers, and they were making it because I still expected the same things of them. I expected them to go to a higher level. Maybe they didn't always meet that challenge. And sometimes kids, we have to look at how we grade, because sometimes we grade on the wrong things. And also I think that if we believe in a growth mindset and that students learn from making mistakes, kind of like what I said about grading, I'd make my tests out of more points. That way I could put the harder questions already mixed in. I did that even when I taught Algebra 1, because I used to give extra credit, and then only certain kids would do the extra credit, and the other ones would just be like, I'm never going to get that extra credit question right, so I'm not even going to try it. So when you make your tests out of more points than 100, and you mix those harder questions in, then every student tries every question. And I just say, it's also test taking strategies. If you don't know how to do this one, you do the ones then you come back and think about the other ones. But then when they come in and correct their tests, then they learn how to do those harder problems. I think we can also do things like, when I was teaching Algebra 1, I would say, you can solve this problem, and if you can solve it one way, you get 5 points. If you can solve it 2 ways, you get 7. If you can solve it 3 ways, you get 9. You know, so you're getting points for solving it maybe graphically, analytically, in a table, all these different ways where you can get students to maybe think about different things and, you know, pull it together. But we can attach our assessments to those things, but we have to let kids make mistakes and feel like it's okay. And that, you know, I have kids that make not such good grades, and I say, just come in, it's okay. Come in, learn how to do it. If you don't know how to do it the first time, that's okay. And some of those kids, you know, that maybe never had exposure to some serious problem solving and thinking, all of a sudden, like when you keep pushing them and encouraging them, it's all of a sudden it like clicks in and they're like, oh, that's what I'm supposed to be doing. But if we don't allow them the opportunity, then that doesn't happen.
Oh, that's so true. I love the one part you mentioned about the idea of showing what you know in more than one way. And you think of it in terms of the idea of a career in STEM. It's often where you're presented with problems and you need to solve. I always think of just a person, or one of an example I always remember, of course, is the Apollo 13 mission. I mean, the idea was they knew how to do one thing, but then when certain things happen, you got to know other ways on how to accomplish that, given what you've got. And that is a really important skill. And as well, to learn from mistakes and to be willing to do it. I know almost for me, when I was a student in school, there'd be almost a fear of trying to make a mistake. You'd be afraid to. And I appreciate teachers like you that are out there now and realize and helping students to realize it's okay. It's a learning opportunity. And I think that's a great thing. Just got another question that's coming in. I think this is another one I think that's probably valuable to explore. He says, when you take a look at students and their potential, where they don't believe that they have that potential, how do you identify students for STEM or for engineering path, and how do you help them to see the potential that they may not be seeing?
Well, you know, I had the same problem myself. And so it helps me to see it in other people. When I first started teaching, I taught like a year and a half. I left teaching. I was coming back. I applied for a job to teach Algebra 1 and physical science. And they called me and said, we want you to teach AP Physics and AP Calculus. And this was a school in Columbus, Ohio. And I was like in a panic, thinking like, I wasn't great. I mean, I was not stellar in those courses. And so I called them back up and I said, I don't know if I'm the best person for this. You can probably find someone else, because I applied to teach physical science and Algebra 1. And they said, well, you're the best person we can find. And if you don't teach these, you're not going to be able to offer these courses. And so then I thought, well, I guess I can't be worse than nobody. But that was my own sense of not really understanding what I could do and what kind of potential I had. And so I studied like crazy the first year, working problems all day, every day. But I learned a lot about myself and that I could do more than I thought I could. And so I see that in other kids as well. And I think a lot of times we write kids off and we say, you know, these kids don't care, or, you know, a kid turns in their paper and they have nothing on it. They didn't even try the problem. I give it back and I say, hey, I know you can do this. Show me something, try something. I'm not taking a paper like this. I'm just not taking it. And so, you know, I keep encouraging them. And then, you know, eventually they start realizing that they can do something. Even if they only get part of the problem, they get some points, and then I can say, now I can talk to you about what you know how to do. And then here's the part where you're having trouble, because a lot of times kids, like, they have trouble in one thing. And so they all of a sudden think, I'm just not good at this, or it might just be one little thing that they're missing.
That's good. Oh, excellent.
Lots of great kids out there that have potential.
That's good. Yeah, and it's wonderful you touched on your own personal experience too. I think that really can help for students to see a role model in someone like yourself. And I even love the comment you made that you were, I didn't realize that about you, that you were a former cheerleader as well. I mean, so that's, yeah. Well, we don't have time for cheers today, but we'll keep going. Okay. But another one that's come up, and I'd be interested in this too, that's that this question that has, you did this talk in about 2 years ago now at our conference in 2018. How have things changed, or have you seen any change? Are things starting to uh, progress more? Or do you think things are better than what it might have been 2 years ago?
I looked up the data and it's pretty much the same. I mean, systemic
Okay.
change is hard, which kind of goes back to that first question. I think even if we do things, you start doing things in high school. I mean, we've really got to come to an understanding across the board that if we change the way that we're working with kids, more kids will be successful. But I think a lot of that is good professional development, understanding how we do that. I don't think anybody wants to keep kids out. I mean, my daughter's advisor in college, she said, I'm going to take physics. And the person said to her, that's hard, right? But did not say that to my son when he signed up for physics. So, I mean, there are all these things that we say to people, and sometimes we think we're helping them, but we're not. So we need to understand that there are better ways to say, okay, great, that's going to be challenging. And if you have trouble, you come and see me and we're going to help you. Instead of, well, that's hard, right?
Right.
So, I mean, I think, things have not changed that much.
Yeah. Okay. Well, it was continuing in the process. We've still got a ways to go, it looks like, and I think I appreciate the work that you and others are doing to make that happen. Looks like we've got time for maybe a couple more. I'll try and squeeze in two more questions here. I think there's one that's come in that says, do you ever refer to mathematicians or scientists in your classroom that can help students see their own reflections in STEM career? And I know on the video you did show a picture, and I mean, I've seen them too. They're all these wonderful, and here it is. I'm talking about white males, yay, that. But have you talked about? Do you ever talk and refer to mathematicians and scientists for your students that are outside the traditional?
Yeah, and post pictures. Sometimes you don't even have to do a lot of talking, but you can post things and show things. And I also work with physics camps for young women, and we do a lot of that with those girls too. People like Debbie Sterling, who was an engineer, we might show her YouTube talk or, so yeah, and that's important. And that they see visual pictures too.
Oh, that's great. And related to a bit of that is your work, and I wanted to make sure we get this question in. And I think it's a good one to ask about, because you are working as one of the Einstein Fellows over the past year. You're one of a select group that's has an opportunity to work in Washington. Can you talk a little bit about that and how that's maybe changed what you believe or have learned with respect to STEM?
So the Einstein Fellowship, I just finished my fellowship in July, so it was 11 months. And I worked in the House of Representatives on legislative problems and issues with Representative Deb Haaland from New Mexico. I worked on her staff. But at the same time, we had a cohort there were 9 of us who worked in different areas. So there were, besides working in Congress, people at NASA, the Department of Science, the Library of Congress, and NAVSE. And so we all had this cohort where we did things together as well. So we went and met with people at the Department of Education to advocate for STEM. We met with the White House Office of Science Technology Policy. We had great professional development activities, met Bill Nye, the science guy, did lots of cool things, but learned a lot. So I learned a lot more about how policy impacts education, and also how the things outside of education impact our students. How many evictions and families that are struggling with homelessness and putting food on the table and all of those kinds of things. As I went to New Mexico and saw schools on tribal lands where they don't have water, clean water, and they have to truck it in. And so it really makes you much more, it made me much more aware of all the issues that are impacting our students and the kinds of things that how policy really impacts our lives and how
Wow.
it is.
Sounds like a wonderful experience.
Fellowship
Really,
is open. Let me say this. If you want to be an Einstein Fellow, the application process is open right now. It closes in November. So check it out.
okay. Wow. I mean, it sounds like, as you say, a wonderful opportunity for you, as you say, to experience really what STEM is about, the idea of solving problems, real world problems, and that people have to apply and take their knowledge of maths, of science, and really think of the idea of STEAM, of even the arts and aspect of all of that together with technology and how you can make improvements and change things for the world. That's wonderful. We looks like we do. I was just told we got less than 5 minutes, but I think we can fit one more question in, or we'll give it a try. So this one is from Al. It says, I know micro messaging is a way educators might gear students in a certain path in their education journey, unintentionally, it says in parenthesis. What insight do you have for current teachers or future educators to avoid this idea of micro messaging?
Yeah, so, if you don't know what that is, that's like telling my daughter, oh, you're going to take physics? That's hard. That's hard, right? So we do these things and we think we're helping, but I think it's just, we've got to become more aware of trying to treat every student as individuals and really trying to, like I said, we don't mean to say these things, but I have had lots of people say things to me over the years that really I stick back in my mind from high school, even, a teacher saying something to me. And so that's why it's really important to make sure that we're encouraging our students and maybe asking them, trying to get to know them. What are you interested in? What do you want to do? And trying to let them know, build up their confidence and let them know that even if other people might not think they can do it, that you believe they can do it and that there are paths to do that and that you're there as a support and a help for them. But we have try to be aware of our own things that we say.
Yeah, so true. I was thinking of, we did a book study with T3 Learns, our T³ community, and it was on the book Blind Spot, and I found that was quite a wonderful read and a very appropriate in terms of particularly these days and thinking of our potential blind spots when it comes to diversity and equity and that. And I think it's important and to realize that some of the things we may unintentionally, I love that in the fact that Alan's question put that in, it can be unintentional. We may not mean to do it, but I think we need to look and recognize that when we are doing it and watch for signs. So I want to say thank you so much. I mean, we got, let's see, I'm looking at the time. We've got 2 minutes. I'm wondering whether I can fit in a question. Do you think, let's see. Well, it's what I say. You had 7 minutes for the topic. You had a few minutes here to chat with us. If you had you have 1 minute or so left. Is there anything else you'd like to share?
Well, 7 minutes was a rush. The most important thing to understand is that students in our STEM classes want to succeed. And sometimes even if we don't, sometimes people think like this kid really doesn't care. When you actually talk to those kids, you find out that they do care, but they just don't know how to go about being successful. So I think it's important to put them in teams, help kids work together, find strategies. I think working in groups and getting in a team helps them for their future as well, so that when they go to college, they understand that finding a study group is an important thing. And that was one of the hard things for me when I was in college, is I felt like I didn't have anybody to study with, and I didn't understand the value of that when I got there. So those are kinds of important things that we want to show students and give them support. We want to teach them the skills and how to think through a problem, give them big challenges, but also support them when they're struggling and encourage them and say, you can do this, and we know you can. And when we do that, we're going to get a lot more kids who believe in themselves and do it as well. So.
That's great. Good advice. I mean, very good advice in terms of that. And if you think in terms of preparing the students that we have for the future, for the work world, it is the idea of working as teams in in your projects and the various different things they need to do. I think that's important for success for them in their.
Let me say that I think the teachers have to pick the teams and the groups, that when you let students choose their own groups, as I said in the video, they'll choose based on other things that don't provide and promote equity in your classroom. And that's a big goal for us, is that every student is successful and not just some.
Wow. Well, thank you so much for joining us, for everyone tonight. And thank you very much to Linda for sharing a little bit more, not just the 7 minutes, but beyond that. And I actually would love to continue to pick your brain in terms of things. And I look forward to opportunities to continue to hear from Linda at various conferences and so on. We're looking forward to joining. If you can join us in the future weeks, we're doing this for the next 7 weeks. Each night. Next week, we're going to hear from a biology teacher, Jessica Cahoot, as she reflects on an activity that actually brought real world science to her students in the city of Baltimore. We're going to get a chance to hear from her on that in her presentation at the 7 for 7 that she did. Be sure to join us also for the virtual summit on October 24th. It's on, you can see more details on education.ti.com, and look forward to seeing you in the weeks to come. Thank you and have a good night.